All right, guys, in this video, we're going to practice converting these polar forms into rectangular forms. So again, I want just x's and y's instead of r's and thetas. So in this one, I'm going to use some ideas that I know x is equal to r cosine of theta. So if I'm trying to transfer from polar to rectangular, I'm going to try to remember these two bits of information. So in this one, the part I'm going to use is that r cosine of theta. I'm going to replace that with x. So this is just x is equal to -4, and that's it. All right, in the next one, I'm going to use that same bit of information. I know x is equal to r cosine theta. So I'm going to replace r cosine theta with x. So I'm going to say 4x is equal to r squared. And the other thing I need to remember is that r squared is equal to x squared plus y squared. So I'm going to replace the r squared with x squared plus y squared. And from here, technically it's in rectangular form, but I'm going to just solve it, make it look a little more familiar. So what I would do here is I would subtract 4x from both sides, plus y squared. And what I want to do is I'm going to complete this square with this x part. So I'm going to say, in order to complete this square, I take half of -4, which is -2, and square it. So I'm going to add 4, and I'm actually going to add 4 to both sides. And then plus the y squared. And the reason we do that is because now I realize that this is equal to x minus 2 squared plus y squared. And I recognize now this is a circle with center 2, 0, and the radius is 2. All right, one more. This next one's a little tricky. What's going on here? So I've got to realize, okay, x is equal to r cosine theta, right? So this time I've got r's over here, and then I've got the cosines over here. So maybe I'm going to multiply both sides by this denominator. So if I do that, now I have 4 is equal to 2r cosine theta minus r sine theta. So I would just multiply them by r, but I'm going to put them in that kind of form. And now I realize that, okay, r cosine theta is x, r sine theta is y, so I have 4 is equal to 2x minus y. Solve for y, y is equal to 2x minus 4. That would be the rectangular form. All right, we're also going to go ahead and talk about the slope of a curve in polar form. So this kind of got messed up. That should say, okay, the curve in polar form is given to you where r is a function of theta. Then its rectangular coordinates are given by x is equal to r. In this case, it's going to be f of theta cosine theta. And y is equal to r, in this case, function of theta times sine theta. Then the derivative is going to be very similar to parametrics. It'd be y prime of theta over x prime of theta. Okay, well, y, I'm going to look at this and realize, okay, to take the derivative of y, I'm going to need to use the product rule. So it's going to be the derivative of the first times the second plus the first function times the derivative of the second. The derivative of sine is cosine. So that's the derivative of y. And I'll take the derivative of x and put that on the bottom. So product rule again. The derivative of the first term, so f prime of theta, times the second term, plus the first term times the derivative of the second term. But the derivative of cosine is negative sine. So I'm going to make this a negative here. So it's negative sine theta. So that's how I'll find, and that's the formula I remember for derivative in polar. So if I want to find dy dx, so that's in rectangular form. So if you're graphing these polars, which we're going to do in a second, we're graphing these polar equations, but the slope at a moment will be in terms of dy dx. That's the slope at an instant. Instead of remembering this, I think it's easier to remember that, okay, it's just going to be y prime over x prime. And then I remember y is the function r, r is in terms of a function, times sine and do my product rule. So I can't remember this, but I can remember this with product rule will get me that. So it takes a second to get there, but I can get there. So let's do one example here, and then I'll wrap up this video, and we'll just do some graphing in the next one. So it says, what is the slope of the line tangent to the polar curve r is equal to 1 plus 2 sine theta at theta equals 0. Now in a minute, we're going to learn how to graph this stuff, and it might make a little bit more sense, but just without even thinking about it, it's the same as before. So dy dx gives us a slope at a moment. This is going to be equal to y prime of theta over x prime of theta. And you might want to write small on your notes. Okay, x is given to us as the r number times cosine, and y is r times sine. But in this case, r is equal to this function, so I'm going to replace r with that function. So it would be 1 plus 2 sine theta times cosine theta. And my y is given to me by 1 plus 2 sine theta sine theta. All right, to take the derivative, I find the derivative of these terms down here. So finding y prime will be a product rule. So it's the derivative of the first part, this is the first part. So the derivative of that would be what? 2 cosine of theta times the second part plus the first part, just like it is, times the derivative of the second, all over the derivative of the x component. So I'm taking the derivative of this part. So the derivative of the first part would be 2 cosine theta times the second one, cosine theta, plus the first part, 1 plus 2 sine theta times the second part. But the derivative of cosine is negative sine, so I go back and I'm going to change this to negative. All right, so there's the derivative, but we got to find out what's that derivative when theta is 0. So dy over dx when theta is equal to 0, I'm going to plug in 0 everywhere. Okay, so cosine of 0, okay, cosine of 0 is 1, right? So this would be 2 times 1 times the sine of 0. Sine of 0 is 0. And then plus...
I'm sorry to bother you. Is Miss Poe here today?
I don't know.
Okay.
Okay, sorry. So this would be plus, and then, okay, plug in 0. So sine of 0, we said that was 0, right? So it'd be 1 plus 0. Cosine of 0 is 1. So this would be 2 times 0 plus 1, so it'd be 1. And then on the bottom, plug in 0. Okay, cosine of 0 is 1, so 2 times 1 times cosine of 0 minus, okay, sine of 0 is 0. So I've got 1 plus 0 times sine of 0, so this would be just 1 over 2. So the slope of our polar curve, the moment theta is 0, tells us 1/2. Thanks for watching this video. Hopefully it helped. And if you have any questions, next time I see you in class, make sure you ask. Bye.